Well, we'll hit go go go, and we'll see if you can get your internet connection working. It seems like it's working this end.
3 different browsers. I can't see the stream. I'm not going to learn anything.
Oh dear, the joys of traveling, right?
Oh yeah.
Yeah,
Last week my truck broke down. This week I tried a
that's
brand new truck. I like living on the edge, brother.
that's why we couldn't stream last week because you were having car troubles, mechanical
Right.
issues, issues.
Right.
But this week we are finally going to get around to wiring this Toads board up. I think we've got a few people jumping in the house, so let us know in the chat if you're in, and if you've also got some of these boards as well, because we've had a few of these out in the wild now.
And what channel you're watching on? Yeah.
Yeah, we have. I've got 9 boards left, and you've got none. But
I've
the
got
number one
none.
thing that everyone's going to ask is when are you getting some back in stock? The USA stock.
You would actually know the answer to that better than I would. I know that they're in the air.
They are in the air. Yeah, I haven't done a look over the weekend, but on Friday they were definitely on the way.
Oh, and Cooley wants to know when the daughter boards will be available.
Yep. So they arrived on Friday here, the final batch for testing. They have just got a couple more tests to do, but I think that they'll be
Jim.
available. I think that they'll be available I've still got to ship some to the US. That's the longest part it's going to be. So I don't know how long it usually takes for the shipping to get to you. Probably about 2 weeks, week and a half.
2 weeks or so.
Yep. So I'm going to do some testing on that today, but I think we're all looking pretty good. The LED is still a little bit bright on it.
But it's all we can do with
LED.
the parts shortage and everything going on. Yeah.
Yeah. Yep. So I was trying to find alternatives, but there were none. So, but that's okay. It'll be fine.
Just take a Sharpie and color it.
Yeah. Yeah.
It'll be fine. We're hams. We make stuff work.
Looks like Ken's waiting for the daughter board too, so that's good.
Well, Ken, we're going to show you how to wire it up tonight without the daughter board. We're gonna get ham.
Yeah.
We're gonna go ham. If you know what going ham means, that's an entirely different funny sidetrack. But yeah, we're going ham tonight.
Jim's watching on my channel because it adds 3dB. So
I told him that was rude.
How did Ham Church go?
I wasn't there. I was driving. So we are in the mountains of Colorado, and 7% doesn't sound like much of a grade, but 7% on a truck you've never driven over a 7% grade. I mean, your typical grade is like 3%. So we're 4% more than typical. So it's like this instead of like this.
And trying to get up that is a real pain.
It's one thing to drive your car up something like that. Yeah, I'm not getting up there as fast as possible. It's another thing to have your engine break down on you while you're towing your entire lifestyle behind you, and you think you might start rolling backwards down the hill.
Thank you, Jody, for the 7 Canadians. Patience is a virtue, but hams be chasing. Yeah, we're trying. Like we I think we said this in a previous stream that we've got day jobs and that we're trying to get these done as quick as possible, but we're still very excited about this. I'm just checking to see where your order actually is.
Yeah, and Frank is saying 7% is chump change. Frank, I don't have 2,700 horsepower per engine plus 4 engines. Let's start there.
So I can say that 2 days ago, I'm not sure what time. I think that's my local time. So over the weekend, it arrived in the US. So
did you move me? I don't mean to do that if I did that.
I did not move me. I did not move you. They are in the US, so that's good. So they're ready to. They'll probably be there. What's it, Sunday over there? They'll probably be there tomorrow.
That would be so awesome. Hobo all the way. Just live on a train full time.
Jim had brother Freddie this morning. So very good.
Brother, deacon, acolyte, martyr, saint.
Which one are you?
All of the above. I'm a fellow pastor.
So what are we doing today?
We are going to wire up the Toads DI, the digital interface that the Toads Club has created, and we are going to get all of these parts and talk about why we need these parts and what these parts do and how we chose these parts. And I think we're going to do audio first, so you can get audio from your radio in and out to your computer. And then if your radio does Vox, then you can actually transmit stuff. Like we could, if we get far enough in the process today, we could actually get some FT8 contacts and make some contacts with y'all in the chat.
If I had a radio that I could,
if you had a radio
that did SSB, I've got
which radio do you have today?
Well, the radio that I've got is just let me show the one I prepared earlier. This is the only radio that I've really got is a Philips. It's just a Philips old
awesome.
2 meter, a Philips 70 centimeter radio. The good thing about these is they have, see on the back there, they've got a DB15 connector, and they've got all the pinouts that I need on the back. Now this is very
totally standard.
Well, this is very similar to what Freddie got his. He got his running on a Motorola GM300. So this is where it comes into, you're not restricted to what radio you're going to be running on. So all the pinouts are on there. Unfortunately, it's FM only, so I can't do. FT8 over FM, I guess I could probably try sending FT8 over FM.
You could talk to that one person who's also listening because of the capture effect of the frequency.
On 70 centimeters. I'm sure that there's someone listening around on FT8 on 70 centimeters. And
YouTube is acting funny for me.
Is it? The actual YouTube?
Yeah. The actual YouTube. So I'm going to look at all signals on FT8 on 70 centimeters in the last 15 minutes in the United States.
That's not going to be many.
Yeah, I can't imagine. So there's problems with having to be local line of sight. There's problems with 70 centimeters and its propagation characteristics. And then there's the fact that nobody's doing it. So you're talking to yourself. However, we could do Winlink if you have a 70 centimeter Winlink gateway. Or we could do APRS again. It's the same thing. You have to have a digipeater somewhere that's listening. But we can make the radio chirp out loud, and then you can listen on your Kenwood, I guess.
2 meters might be a little bit different. Oh, have a look at this. This is 2 meters. Someone is doing...
Holy moly.
2
there's
meters.
Something wrong with that.
Actually, 2 people are doing 2 meters from Tennessee and Alabama down to Brazil.
So there's no reason why that couldn't be moon bounce.
Well, I'm just looking here at the frequency they're reporting as 144.175. So
thank you, Chris.
It could very well be 176.
That's amazing to get that kind of propagation. They've got to be going through a bird.
The other thing it could also be is a thing called trans-equatorial propagation.
Well, you've got line of sight issues on 2 meters. I'm speculating, of course. Don't think I'm arguing with you. I mean, you've got curvature of the Earth, so you can only realistically get 30 miles. So if both of those got to the equatorial duct within 30 miles and then ducted across the equator, it's possible.
Right.
They look about the same distance from the equator.
Right. So quick.
That's way more than 30 miles.
Right. So quick education session then. So obviously the equator runs through the middle of the Earth here, the middle of the flat Earth, because it's flat here on the screen.
It looks flat to me, yeah.
And what happens during, not necessarily now, but during daylight hours around midday to 2 p.m. I think is the local time is the sweet spot, but it can happen at other times. You get like these charged ionized portions or bubbles here on the equator that occur due to the ionization from the sun. And if you get a signal into that, you can reflect off of it. Now, obviously, like T.O. said, you can't get from, that's halfway to the equator there. That's a long way. So then what it relies on is sporadic E hopping to get to that point there to continue on from there on.
So it's got to be 30 miles to the opening of the duct or 30 miles to the sporadic E, and then from the sporadic E to the opening of the duct, and then through the duct and out the other side.
No, not necessarily, because sporadic E is quite high up in the air. So depending on the height of the sporadic E cloud, as long as you can see it up high up in the air, which, you're limited to the curvature of the Earth with, your line of sight or whatever. But if you could see right up into the air and you could see the duct that's up high, which is much greater range, much greater height, that's something like I'm trying to convert off the top of my head, 2,000 kilometers, or not 2,000, 1,200 kilometers. What's that? 700 miles or something like that. So we have the same thing here between Japan and Northern Australia. So Northern Australia and Japan is roughly about the same distance to the equator. So we can do 2 meters from there to Japan. It's quite rare. It's quite hard to do. It's just interesting to see. So Mike's
got to be very rare.
Mike's talking about, because you're currently are you in summer yet? Yeah, you're in summer or close to it.
Yep.
So
we
get
just passed the longest day of the year.
So 6 meters will be. Let's go to 6 meters. That should give us a few more lines. Yeah, there we go.
Yep.
A few lines going on. So it's open. Anyone who says 6 meters is open is not open, sorry. Anyway, we strayed off the topic.
Did we, though?
This one station's, what's that? Japan from California, it looks
California?
like. Is it?
Yeah. That would be awesome.
Japan's local for us. We all the time. But 70 centimeters, no, probably not on FT8. Anyway,
but if we can hear the signal, we'd be pretty happy to hear it.
Yeah. Yep.
FT8 itself doesn't care if you run FM or single sideband or AM or whatever. It's just sending out doodle-doodle-doodles.
How does that go?
Doodle-doodle-doodle, 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 doodle-doodle-doodle. Don't you listen to FT8 all day in the background?
Of course. Cool. All right, so should I move over to Benchcam, and then we can ask questions and do things. You're going to have to watch the chat though, because I won't be able to do two, because I can't multitask. That's the problem. I can't multitask.
Only the best of us can.
Yeah. Actually, one thing you talked about, I should point this out. You talked about EME. We did that the other night.
That was awesome.
I
wish I was there.
So we went out to an open night for the Astronomical Society down here, and they've got. I'm just bringing up the photo here now. They've got a very, very big dish. This is a 20.
Check out the size of that dish.
That is a 26-meter dish.
Look at the dish on that one. I'm trying really hard.
Yeah, I know, you're trying. Keep going. I'll find.
That's not a dish. This is a dish.
Find a bit of photo.
The one and only Australian movie we ever got.
No, you got Crocodile Dundee.
That was what I was talking about.
Oh, was it? Oh,
you call that a knife? You call that a dish? This is a dish.
There you go. 26-meter dish. Big dish. We didn't use this one, obviously. But what we did do is we used this, the small little dish.
I've seen that. That's on a trailer you guys carry around with you.
Right. Here it is.
Yeah.
So there's the dish. And that was pointed at the moon. We were bouncing signals off of the moon here. So there's a photo of the... not a photo, but there's a camera image of the moon. We have a camera mounted behind a rifle scope on the side of the dish, and you can actually see the moon through the crosshairs. Here's the signal that we're receiving back from the moon. And funny enough, the station that we were communicating with was only like 15 miles away in the opposite direction. And everyone says... Well, how do you know that you went through the moon? You didn't go directly, because WSJTX shows you the time delay.
Yeah.
And it was, 2.5, 3 seconds.
I thought it was 8, but no, at 8 is the sun. The moon is closer.
And we're doing 7 minutes is the sun, I think.
Yeah.
But this is seconds. And then we did some satellite contacts as well. So, yeah, that was cool stuff.
So what's the station there? Looks like a 9700 and...
Not 29700s.
Okay, 297. Usually people run amps when they do this too.
So this 9700 here is running to, where's the back of the dish? The transverter and the amplifier is in the back of the dish here, because this is running on 10 gigahertz, so you don't want cable loss. So you mount all the transverter and everything in the back here, and then run a cable back to your 9700, the IF cable back to the radio here. And then my one was just running like 5 watts or something barefoot into the Arrow antenna for satellites.
Nice.
So it wasn't really that.
Well, for satellites, you don't want to hit them with a lot of power.
And all running off the little Anchor Solix power station down here, which works.
This stream
well.
not sponsored by Anchor.
No.
Or is it?
No. So, and we had people, the public. So the idea was the public came through here and they were looking at the satellites passing over here, and they were looking at the cool dish. And this is automatically tracking, like that automatically tracks the moon.
As the moon moves, yeah.
Yep. And it moves very fast.
This stream sponsored by viewers like you.
So yeah, that was rather cool. All right, I'm going to switch over to my bench cam view, and I'll see you on the other side.
Okay. So while he's gone...
Still listening.
I know. I don't care if you're listening or not. I'm still going to talk about you.
Okay.
Now he's not listening. Ha! Now he's listening again. Hi. I guess we're not behind the scenes anymore. So Prime Day is coming up. What are you guys looking forward to get on Prime Day? What kind of deals? What kind of gear? What are you hoping for? Batteries, radios, HTs, base stations, mobiles, antennas, anything special? You got your eye on? Because I don't even know what all the stuff is. I know some of the stuff from some of the specific radio manufacturers, but there is a lot of stuff out there. Let me get this thing arranged up. Me and bigging it so we all can see it. Look at that. Man, those are nice parts bins. I'm a little jealous.
What?
Hi. You're a little hot.
Hi.
Very hot. Hold on, let me
Audio test. Audio test.
You're getting better. You're blowing my eardrums.
Muting myself. Stand by. Got audio issues.
Frank, I can vamp with the best of them, bro. Don will not be buying a QRP 2-meter radio. How did I know you were going to say that? I almost prompted you, Don. I have no idea. Like, if I have 3 different browsers and 2 different devices on 2 different internet connections, and I can't bring YouTube up or YouTube Studio up to see what's going on. But y'all apparently are watching on YouTube. We got 138 of you. I don't know how that breaks down because I can't bring up YouTube to see, but so in StreamYard, it says 136 people are watching. Is that 136 of you are watching the stream combined on both channels because we're streaming to Hayden's channel and to my channel? Or is it 136 on Hayden's channel or 136 on mine? 74 on Hayden and 62 on TO. 74 plus 36, I have to do it in a calculator, 110, because I went to public school. Funny story about that. Hayden, where'd you go? I guess we'll just go back to that view. There we go. Ken, you're on Hayden's stream. So if you would like more information on this board, what this board is, it is a CM108 chip that has a USB-C port on one side. The CM108 is a native USB device, so it'll run on any flavor of USB that you want to stick it on. We chose USB-C because it's 2025, and that would be the smartest connector to start a brand new interface with, wouldn't it? And then on the other side of the chip, it puts out pin headers. And you can either solder directly to the board or you can put on the standard Raspberry Pi type GPIO pin headers and you get audio in, audio out. There is some power there, but I wouldn't use it to power anything serious because I don't know how many amps it's good for. It's 3.3 volts and 5 volts. Oh, there we go. Bench cam back. Move that over.
Can you hear me now?
I can hear you now. And then you also get a PTT signal and a carrier. Is it carrier operated squelch or carrier on squelch or carrier open squelch or whatever? What is it, Hayden? What's the O?
Carrier.
Oh my God.
Operated
squelch. So it's my understanding, and we're going to talk about this a little bit. It's my understanding that the radio says the signal is busy, don't interfere. and then the computer respects that because of the COS line, the carrier operated squelch. And this is fantastic for Allstar, but not something you really need for APRS under Direwolf, and not something you need for Winlink. I don't know that they support it directly, but only because I haven't dug in too deep.
Now
This cute little purple board on the left is mating up with this green board on the right, and they're going to have a fun evening.
The dev board. I don't know what my audio is like at the moment because for some reason it's not using my headset audio. So you're probably going to get all the bangs and clangs like that.
It's perfectly fine. Can you hear us fine?
Yeah. I can.
Yeah.
So dev board on the right and your boards,
production
you get
model.
The purple ones
Shipping
on
model.
the left. Yeah. So I should give a sneak peek at this too. So this is the finished daughter board. So there are a couple of changes with the LED, obviously,
Right,
and these pots are now aligned. And I've also made sure that the logos are aligned now, or better aligned.
Did they sneak a number in there? What is that? Is that a serial number or something?
Yeah, I think so. I think it's a file number. They did it on this one too.
Rude.
I know. Didn't even tell us about it. So if I plug that in and then we give this some...
So Lee's asking if we plan to do boards in red. I know why you're asking about that red. And I think the answer to that is yes. But what I think we're going to do is the DI6 is green, and then the DI RJ45, the DI9, the DIK connector, they're all going to... The DIK. We can't name it the DIK.
Yes, we can. We could definitely... We're going to call it... Someone put that in the chat. It's the DIK, okay?
Toad's DIK.
We've just gone and trademarked
christened it?
Yep.
Yeah, so obviously DI6 is going to be the 6-pin interface. We might do a DI13, but the 13-pin interface is a little weird because Kenwood has 2, ICOM has 1, and I think depending on which radio on ICOM you're talking to, you speak a different language, even though the pinout's the same. And then there is the K connector for like your Baofangs and your other radios that have that kind of stuff. So
right.
Different daughter boards in different colors is where I was going with that. Thank you for the prompt.
So I've got a couple of things here. You were talking about my parts bins earlier. These are just, and I've even...
Tant. You missed a letter in tant.
Tantalum.
There's an I in that word. Oh yeah, Yaesu does make a 10-pin. That's true. I do believe you can get a 10 to 6-pin cable adapter pre-made, but some of the Yaesus have 6 pins, which used to be a standard. Some of the Yaesus have 10 pins. I think I have both. I think I have a radio that has both a 10 and a 6.
So I don't know about you, but I use standard colors for my connections, and I'm just getting these out of an old Arduino box of cables, so I don't even know if they're going to be long enough. They might be. Ground.
Tantric caps, yes.
Tantalum
caps. Tantalum.
Tantalum. All the white audio. I'm going to have to use orange. I don't generally use orange, but my standard
colors.
My standard coloring schemes is I use white for transmit audio. I use
Why is it got to be white?
because this is what I've used for years. Don't make this a... I'm not going there.
Right.
Yellow received audio. Blue for carrier operated squelch. Green for PTT. Black for ground. And today we're going to have to use orange for the audio because the white one's too short, I think. So
over here we call those DuPont wires.
Nice. I don't know what we call them. I just call them wires.
They come in jumper wires. Yeah, they come in male, male, female, female, male, female, and female, male if you turn them around.
Right. And for those that use the breadboards, this is the layout of what the breadboard is. They've got the columns and the rows, and all of the columns are labeled A, B, C, D, E, which is on here. And they're all connected together. And then your 1, 2, 3, 4, or your 1 to 30 are the ones that aren't connected. So you got to be careful that you don't create any short circuits. So they got
I didn't know the
basic stuff
columns
here
were
for the
connected
Arduino
together.
stuff.
I guess that makes sense. I've never
Yeah,
tried.
so if
I've never
I get-
gotten that far.
So if I get here,
No, the columns
and-
can't be connected together.
these two, have I got that right? Around the right way, or have I got that wrong?
So that right there, the green and the black are now connected to each other electrically. But if you put
Yes.
the green next to the black on, what is that? I can't read it. Column E, they're not connected. Yep,
Oh, listen.
those are connected.
Now, if I go, say, down here, both on E, they're not
Those
connected.
should not be connected. Yeah, so
Yep.
vertical columns, lettered columns are not connected. Horizontal columns, numbered columns are connected. You said it backwards, but I knew what you meant.
I think it's because they use this in here. They use the term column and row. Yeah. So yellow is the row, and then blue is the column. So if you're in the same row, but a different column, then it's connected. But the different rows are all isolated from each other, if you know what I mean.
Yep.
Just had to clear that up. Bryant's right, though. Depends on how you lay it in front of you. You're right, because if I do that or I do that, it's different.
Yeah, what's a column?
Yeah, exactly. Okay, so what are we going to start off with?
Well, we need to connect the DI to this.
Right. So what I've got is, did you want to start with audio first, or do you want to do signaling? Because I've got all the parts here for signaling, so we can do that.
Well, if you've got all the parts for signaling, we can do signaling. What I would like to do is we've got an infinite amount of time. I don't know how much time you want to spend on this, but we're at the 30-minute mark almost. So whatever would get them to a successful connection to their radio fastest.
So I don't have an infinite amount of time, but I can see if I've got some pots. This is the problem that I had before. So the basic parts list is on the guide. If you can bring that up, Tio, so that we can show through that.
Sure.
So
I
what
might be
I've
able
got,
to do that.
So what I've got here is I'm just looking at my values of my potentiometers, and they're to 20k pots, so they're probably not enough for what I want. I'm going to need some 104s. So the way that we read these is, I'm not sure if, I don't think I can see that without zooming up. So you can see how it's got 103 written on it. So it's 10 and then 3 zeros after that. So 10,000 ohms. So that's 10K.
10,300 or... Oh, it's 10 with 3 zeros after it, so 10,000.
10 with 3 zeros. So 10,000. So
see, I'm playing the fool here.
Yeah. You play the part so well.
Thank you.
I mean, we could probably do it with 10K. It's just not going to be a lot of audio. I'm just going through all of my parts here. See, I've got lots of 10K pots. Well, I must have been doing a project with 10K. But what I'm looking for is a 104 or, a 504 or a 204, because I want a high resistance range so that I can adjust the audio. There we go, 504. That'll do for one.
So what is the 504? You're looking for the number of turns, or you're looking for the amount of resistance that's selectable from 0 to 10?
Right, the amount of resistance. So can't quite see that. It's not good enough. That's 504. So that's 50, then 4 zeros. So that's 500,000. So 500,000 is 500K. 500K pop.
And so the more K, the more amounts of variation you have, or is it still like 10 steps per?
No, the more amount of resistance. So we've got a high amount of resistance to be able to adjust. There's 100K. We'll use that to be able to adjust the audio with.
So you answered the
like
question right, but I asked it wrong. Let me try again. Are there 10 clicks on that? And then if you have a 50K, it's 1, 2, 3, 4, 5.
No, that's actually a good point. So these, and I don't have a screwdriver within hand, these are like a single turn. So you'll adjust, say, half a turn would be 250K. So it's quite a big adjustment. Whereas
It's infinitely adjustable depending on how finely you can turn your screwdriver. It's
Right.
not a click, click, click. It's a sweep.
Right. But the pots that we use on here, and this is a thing when you get the daughter boards that we should point out, these are, I think, 20 turns. So what will happen is you'll be adjusting these and you'll be wondering, why is my audio not changing that much? It's because these are very, very fine resolution. So just if you keep turning them and you get to the end or an end stop, you'll feel it click. It'll click. And that means
And then
you
it
can't
starts
go
over?
any further. No,
Stops
it means
hard,
you can't go
okay.
any further that direction. So then you go back the other way. And then you can make the adjustment. But once we get these plugged in and live on the stream, then you'll see what's going on with those.
And those do two different things. Those do audio isolation, and then they do essentially volume control, so you're not shouting at your radio or your computer.
Right. So essentially, that's what we're doing with this pod as well. We're doing audio isolation between this and the Toads DI board, because we could just put the audio directly from the Toads DI directly into our radio and adjust it in software. But then there's no real isolation between the two. So, if we have a really, really high audio level, we don't really want to go blowing things up. So that's why we put these in. And you can see, so there's the adjustment. There's not much of an adjustment there. So what I'm going to do is I'm going to put that into across, let's have a look here, 10, 12, and 11. Now, I'm not sure if I'm going to be able to fit this one in. We'll have a look. 20, 20. Oh, and I've soldered on the end of that one, so it's going to be even better. 2021. Don't think that's gone in. I'm going to have to find another pot that I haven't soldered to. But most of this is just playing around with different parts and just seeing what works out of the parts bin, basically. I saw that someone in the chat said that they have some old parts from their electronics, from their college electronics kit or something. So it's a good bit of fun. But you had some questions about like what components we're choosing and stuff like that, didn't you?
Yeah, so this project was born out of the Retevis RT95 or the Anytone AT778UV2, or there's a Striker, and I think it's a I can't remember the name of it because we don't get them over here, but I want to say it's like a Simron or something. It starts with a C. Anyway, that's not the important part of what I'm getting at. I wanted to be able to do APRS out of the microphone port on the front because it's got a speaker mic, which means there's audio coming out. There's no documentation for it, and I love a challenge. So this is where this was invented from. And a lot of different people have gone down this path, blazed this trail before me. Oh, use a 1 microfarad capacitor, or use a 4.7K capacitor, or use a 4K capacitor, whatever the next value is. I don't know off the top of my head. But everybody had a different value, and every one of them worked. And so the real answer was use a capacitor. But like, how do you know that? Don has asked this question before. We were doing a club build of the QDX radio from QRP Labs, and I think he was asking while we were doing that a while back.
Well, there are some things that I'm just trying to desolder this, get the solder off this pot so that I can put it in the breadboard. There are some things that you get from other circuit designs, so you kind of cheat a little bit because you use what someone else has come up with. But hey, if it works, why not?
Yeah.
But with a lot of the things like Ohm's law, you would have learnt Ohm's law when you got your license that you can calculate things. So, for instance, like LEDs, if you want to calculate how much current's going through an LED, you use Ohm's law. And it's very similar to doing that with other parts as well.
I'm
you know,
worried why
choosing
you're
the
holding
correct
a
pin.
soldering iron with a breadboard.
I'm not. The breadboard's over there.
No, I mean like in the same room. These two things don't necessarily need to go together.
They're
Like that's the
fine.
whole point of a breadboard is to not solder.
Well, see, my
Solder.
breadboarding is where's my development unit here? That's my breadboard. I just stack components on until it works.
And there's a name for that kind of building as well. There's Manhattan construction where you just build stuff up because it looks kind of like a city.
Yeah, this is MacGyvering.
And then there's dead bug construction. And then there's breadboarding.
There we go. Now it plugs in. Good. I use my trusty big pliers.
We call those lineman's pliers over here.
Right. So what we've got here on this side of the breadboard, I'm not sure how well you can see that, but
Oh, there we go.
So
That's nice.
so we've got the wipers. This third pin here, this middle pin is the wiper. So that's going to be our signal going out to the radio on one side on one of the pots, and on the other side going to the Toads DI board. So what these are doing is these are just essentially they're voltage dividers. So our audio is a voltage, and we're coming in on one side of the potentiometer or trim pot, and then the other side is ground. And then our third connection is either to the Toads DI or the radio, depending on which side we use. So what that's doing is it's just dividing the voltage down to reduce our audio level. So if we bring up this, we can see that demonstrated there in the wiring diagram at the bottom. If you want to zoom in on VR1 there, TO. So there's our audio in from the radio on the top of the pot through that capacitor. Now that capacitor we haven't added yet. We're going to put that in.
We haven't done this yet.
No, that capacitor is just there to block any DC that might be DC voltage that might be coming from the radio. So we don't want any sort of stray voltages going into our board. So what we do is we put a cap there. Now, in that diagram, that's showing a non-polarized capacitor. So it doesn't matter which way you put it in. However, some people have said, I don't have any of those. What capacitor do I use? And you could use a polarized capacitor. Just put the positive side to the voltage source that we're trying to
Which is the variable resistor?
Well, no, which would be directly to the radio side.
Okay. The source of the audio.
The source of.
And then in the other one, it's a different direction.
Yes, that's right. So if you scroll down, you should see that. There you go.
The capacitor's in a different hole.
Yeah.
Different pin.
Sorry, I've got that around the wrong way. Audio out to the radio there. There's that cap. And then we've got audio in on the other side. So different pin.
And so you look at this. Yeah, you're dead sexy with those hands. You look at this variable resistor, and you can see those 3 pins that we have on the breadboard. One comes from pin 5 of J2, which is the microphone pin on the Toads DI, and one pin goes to ground, and then one pin goes towards the radio. We're receiving a signal from the radio, but that pin has to go to the radio in order to receive it.
Yep. So if we go back here, we can then wire one side of our pot. Let me do that and do that. So I'm going to wire. So I mentioned that these are tantalum capacitors, and I'm just using a 4.7 microfarad.
So is it true that all yellow blob capacitors are tantalums, or did I just make an assumption?
No, some are monolithic as well.
In that
monolithic
same form factor.
Similar form factor. There is also disc ceramic capacitors, and each capacitor has a different type of use case. Like I saw someone, I think it was Chris, put in the chat earlier. Some are used for RF bypassing. Some are used for, voltage. Some are used for different
And we're using this capacitor just as a DC block. So we're going to let RF pass, but we're not going to let DC voltage pass.
Right.
Is that right? Okay.
Right. So I've got the positive side here at the bottom. Oh, I'm out of shot. I've got the positive side here. So that's going to be our radio connection. Then I've got the other side here going to our top side of the pot. So now
and so
what
that
I'm going to
lines
do
up
is,
in the same, what do you want to call that, a row or a column? As the two pins are in the same hole, the same set of 5 holes on the daughter board. The numbered holes, not the lettered holes. And so
Yes.
they're connected electrically, as we showed earlier with the multimeter.
Yep. Now I'm going to add a ground in here. And luckily we've got a ground bus. So, and I've soldered to all of these stupid leads.
Oh, you're cleaning them up with the soldering iron.
Well, I was, but I have used a few of them and I don't have that many ground ones left. Oh, here's one. So what I'm going to do is that side of the pot's going to go to ground.
So while you're wiring that up, David makes an interesting point, and this is why we started with the DI with just headers, so that you can do whatever you want, and then we're making the daughter boards just to make it easy, and because we can and we want to learn. And he says, my use case probably won't need a daughter board, so I'm going to get some perf boards and just make something myself. And one of the plans that we have is to make a perf board daughter board, so that way it connects to the headers directly, and then it has a prototyping area directly on it. Not a breadboarding type prototyping area like what he's doing. These actually have, grippy fingers underneath the white shell to grab your wires. This you'd actually need to solder to.
Mm-hmm.
And then John is asking, if you can straddle the middle, shouldn't you? In order to straddle the middle, you need to jump the connection with a jumper wire because they're not physically connected to each other. That's designed for you to put a dual inline package or a dip chip on top of that. So that way that you can connect to the different legs of the chip, and the different sides of the chip aren't cross-connected to each other directly.
Right,
and if your project needs space, then do it. Go ahead.
So what I've done here, which is a bit messy, but I've got 2 grounds here on one side of these pots.
Mm-hmm.
These two connections, so I've got audio, which is going to come from the radio, and audio to the radio. And then this side, I've put my capacitors in, and this side's going to go to the Toads DI board. So that's basically audio now. So I could actually wire this up right now. Now, I'm not quite sure whether I should. The problem is I can't plug this in to the board because it's going to short 2 of the pins out. There's no way that I can actually connect this in, which is a bit annoying.
Right.
And I don't have another breadboard. So I don't know if I'm going to solder. Am I going to solder these directly in to these pins, or should I do it another way? I'm not quite sure.
Well, the cool thing about soldering them in is you can always clean it up later and undo your soldering. Soldering is not permanent. It can be, but it's not.
This is true. So I guess I should do that then. So on the DI board, it does have the pin outs there.
Point to them. All that white text tells you what each of those pins do in order.
Yep. And it's also in the yeah, you're right, John. I don't have any of that. I do have obviously the headers on the top here, but even if I, try to plug that in, 1, it's upside down, but 2, it's going to short out 2 of the pins, so that's not going to work. So this is documented in the manual. So I'm just going to go up from the bottom there. And I'm just going to tack solder those in. Yeah, I'm just going to tack solder this in. Now I've got my
technically,
audio.
you don't have to do that. I mean, you should, but I'm going to should on you. Just having some physical tension there would make it work. But it might, like if you bump it or if the radio moves because it's got more weight than the Toads DI, then you're going to lose your audio connection. It's audio, It's not going to care too much, but oh, look at that. That's a Weller.
It is a Weller. This is how you solder with not enough hands.
Right? I do that a lot.
Now I'm embarrassing myself. So you got to hold the board, you got to hold the solder, and you got to hold the iron at the same time.
That makes Hayden the Wellerman.
Right. So audio's in. Now, we could go and connect this to our radio, but we still need PTT. So that's where I've got this.
So we don't
transistor.
need, quote unquote, but we do need. Like PTT is the best solution, but you can also use Vox, or you could just, this is a poor man's SDR at this point. Actually, it's the same cost as an SDR, but it's beside the point. Single frequency SDR.
Yeah. Right. If I had my other radio, then I could wire this up a different way. What we could
David
do,
must not be American. He's saying that you put an L in solder.
Very funny, Sand. So what I'll do is I'll just put this transistor in, and
so if you look really hard, you can actually see the schematic. I'm going to put it on the screen real quick. You can actually see that Hayden has connected the capacitor to the output of the variable resistor, and then he's going to connect that to the radio, and he's got to connect it to ground. Let me remove that. And then set that back up so y'all can see it.
So do you want to bring that back up and show you that what I'm doing now with the transistor and the PTT and how that works?
Other direction. So that's this one right here that I've got on the screen. And so you've got a 10K resistor going into, so your transistor, you've got a BC547.
Yep.
And NPN on the American ham test, we say not pointing in, and you can see that it's pointing out. A PNP would be proudly pointing in, or whatever it was, I forget at this stage in the game, but you can see that it's going out to ground. So 10K goes in. Is that the emitter, the base, or the collector on that transistor?
Going to where, sorry? To the radio.
The resistor that's going to the daughter board, the DI.
The base.
So it's going to the base. Okay.
So the 10K resistor is going to the base. The collector there at the top of the transistor is going to the PTT output to the radio, and the bottom side, which is the emitter, is going to ground. So what happens is when we get a signal from that GPIO pin, that pin 7 on the Toad's daughter board, it'll go to plus 5 volts, and then we go through that resistor, that R1 10K resistor, which is just a current limiting resistor. It then turns on that transistor, and then it connects the PTT output there at the top to ground at the bottom, just like a switch. That's all the transistor is. It's just a switch. If that makes sense.
And there's a whole bunch of different kinds of transistors. Even this BC547, you've got a 546, 547, 548, etc.
Right, they've all got different characteristics, but for our purposes, we're just using it as a very simple switch, so we don't really need to worry too much about that. If you get something like a BC559 or a different model transistor, that's a PNP, so that works a different way. So you might have some problems if we do that. So now, what GPIO pin was that? Because I'm thinking off the top of my head here. You have to go back.
You have it down as GPIO 3 for PTT.
Excellent. So that,
but it's written on the board, isn't it? Or does it just say GPIO?
It's written on the board as GPIO, which in future batches we're going to have to change that so that it says PTT.
Right.
Which would be good. I mean, GPIO is good because that's the actual pin that's coming out of the chip. And other applications may use different GPIO pins, but for like things like Allstar and Direwolf, they use GPIO 3. I love the smell of burnt plastic in the morning.
Yeah. Which plastic did you burn?
This one on the back of the
okay.
back of the header. Okay, so I've got my dodgy looking setup here. So we could go and essentially hook this up to our radio now. I can find my pre-made cable here, which I can actually disconnect these wires and we can connect that up real quick.
It's a good thing you use standard colors.
I know, right? So you can guess which ones I'm going to be using, can't you?
Right?
So unfortunately, I need to. I don't know where my vice is, so I'm going to have to use something a bit more ghetto.
That's a very loud, clicky camera.
Is it?
Yeah, whenever you zoom, I can hear the click, click, click.
Yeah, I'm pressing the button. That's why. It's because I should have my headset as the audio, but it's not working for me.
You can't be arsed.
Something like that.
Isn't that the radio side? Too late.
This?
Yeah, isn't that the side you plug into the radio?
Correct. Yep. But I'm taking off my old cable because I don't have any of these connectors left.
Oh, okay.
Yeah. So
what camera are you using for your overhead?
This is just a document camera thing that I'm using here at the moment.
It works really well.
Yeah, it's just something I borrowed for today's stream. So if I hook that in there, so that's my audio.
Oh, I see what you're doing. I was thinking you were going to put it on the other end of the wire.
No. So we haven't done squelch, but we can do that reasonably easy. Everyone's probably sitting at home shuddering, going, "What the heck is he doing?" But hey, we're hams. We just experiment and tinker around.
We're doing the hams work.
Ghetto would be vice grips, exactly. So undo the green. So this is why I always use standard colors, because then when I come back at a later date and I find something that I've made, I know exactly what the signals are or what the color scheme of the device is. If I come across someone else's, I've got no hope.
Ken says this is a good ham club project, and that's kind of the purpose of what we're doing here. We're trying to make it so that we can all level up and learn together and get better at this, because you have to start at the beginning. You have to start at the bottom of the stack, and that's really hard these days with all kinds of surface mount components and heat plates and all kinds of other stuff. So
you saw that?
Yeah, I did.
My
that.
My audio, my lead went flying.
So, I mean, you could very easily go buy a reel of the CM108 chips yourself, and you could do all of this stuff, but surface mount stuff is a pain in the butt. So one of the things that we're going to do in the future, once we get a little bit better ourselves and are confident in our teaching abilities, is we're going to go in and design a circuit board live with you guys and then make that available so that you can tinker with the circuit board design itself. But we got to get started somewhere, and this is what we figured was the right place to start, was slightly after the audio interface. Like, we didn't start at beginning, start with the 8086 processor and build a computer around it. So pick a place.
That's right. Right, so we're all wired up.
Awesome.
So I should be able to plug that in, and we should be able to make some noises. Let me see.
So did you add the squelch circuit, or did you not do that yet?
No, I didn't do that, but that's pretty easy to do if you want to do that. So the squelch circuit, I'm just using this little resistor, this little diode here, and you can see that it's got the little black band. That's the anode. Is it right? Am I got that right? I've got that wrong.
I just look at the way the circuit board's written.
Right. So bring up the circuit.
All right. Let's see. Diode.
So that line, no, up the top. That's it, Chris. Black band, block positive.
The 1N914.
Yep, or 4148, just a little signal diode. Yeah, cathode. I knew I had it around the wrong way, Kevin. That needs to go towards the radio. That's just to block any DC, so it only goes one direction.
Right.
So we've got our black band on this right side. So I'm just going to stick that off to the side here.
You're off camera.
There.
That seems like a good place to prototype that circuit. Sure.
And then we've got...
I mean, the basic principle of a diode, and there's different flavors of diodes for sure, but the basic principle is we're going to allow current to flow in one direction. We're going to allow voltage to go in one direction. We're going to allow water to go in one direction and not the other.
One-way tap.
Exactly.
So now I need to wire that into my connector down here. And I need to try and remember... I'm going to have to just look this up real quick and see what pin I need to wire that to while you get to that super chat.
Yeah, so ClinoDev dropped in a free membership super chat. If you are a member and you're in green text in the chat, you get a free one every month, and it's the beginning of the month, so use it early, or is your strategy to use it late? And he says, I can get the I'm an Expert listen to me free at work. Yeah, I know that. I do that too. And then this is actually, it's super interactive. You know, this is going to be, I don't know, how many live streams are we going to do on this? As many as it takes.
Yeah.
And, you know, let's see what happens. Let's make this work. And who knows, between now and the end of time, we might blow up a radio or two. But you start out with a cheap radio. So I have, yeah. So the radio I picked was the Retevis RT95. It's somewhere around 130 bucks. And it's a pretty neat little radio. But you could easily do this with literally any radio that you can get audio in and out of and has a PTT circuit, which is all of them. Or you could do one, like if you just wanted to decode FT8 on an old shortwave radio, you could take the audio out of the radio via its, speaker jack, plug it into this board, and listen to FT8 signals via your computer that way and decode them.
Can you go to the the pinouts? Yeah. So we got to go. The COS signal goes to pin 9 of J2 or the volume down. So I'm now going to get this.
So originally this chip was supposed to be like a little MP3 player or something like that. So it has volume up, volume down, and it has left and right audio out, and it has microphone in, and it's got a little bit of power coming out of it, which is how we're powering the daughter board, which is why you saw that bright green LED. So, we're just adopting that volume down switch to be the carrier on Squelch line, and then computer software, Direwolf as an example, fully supports that. Allstar supports it. Well, Direwolf supports the PTT. Allstar supports PTT and carrier on Squelch. I misspoke.
So the one thing I have been missing is I need to wire in a ground, and I don't have any ground wires left in my bin, so I've completely ruined my wiring standard here. So whatever you do, don't go copying me with my wiring standard, because it is shocking today. So we're just going to use a ground wire for the green wire for the ground.
So Kevin's got a good comment here. How do you think they became experts? So knowledge comes from experience, but experience comes from failure. You have to, don't be afraid to screw things up. So in my case, I mean, we're down the line on this project a little bit, but I spent some money. I spent $130 on an education. I bought a radio. I blew it up. I learned something. That was actually very well worth the money in my mind. If it had been a $2,000 radio, it would not have been worth it. But a $100 radio, sure.
I'm trying to get this in shot. I think it's in shot. There we go. So I'm connected to the back of the radio now. And I'm just going to bend that up so that it's sort of half visible. So now what I want to do is I want to get my USB cable here. I'm going to plug that in, but I'm going to plug in the radio first.
Jody, it counts more, I think.
Yeah. Here's a power lead that I prepared earlier. If I can get it across the bench. Got too many things on the bench here. I didn't really clean up in preparation for today's stream. whilst you're listening to ASMR, Sounds of the Workbench.
Freddie Mac is wanting to support us when we get connected up to Allstar. What's your node number?
I'll have to connect it via another method because my Allstar node's a private node that I've been testing with. But I can bridge it in. So let me just get some audio working first.
Okay.
595.
Freddie, stand by, and everybody else.
Yeah, stand by. 5. I have to look it up. 59598.
59598.
Let me connect that to this private node.
We'll hear all the connection sounds.
Yeah, no, I'll do that after. I think we need to do this first. Okay, we're connected now. I always like to do a bit of a test. I always like to put my finger on the chip just to make sure that it's not getting hot and there's no smoke coming out. So that's a good sign.
Yes. It's also a good way to tell if a chip is bad as if it's way too hot. Too hot to handle.
Right. So now I'm going to turn this on. I think this radio is on 441.5. So let's now turn on our power supply. Not transmitting, that's always a good sign. Oh, look at that. Straight away. If I transmit, look.
Nice.
Of course, I'm transmitting with no antenna. No one in the chat told me that.
I wasn't going to say anything. I wanted to see some smoke.
Right. We'll tell you, there you go. That proves to you, doesn't it, that you don't necessarily blow up your radio by not having an antenna connected.
It depends on how long you do it. Like we were talking about earlier, it's a matter of heat.
Right. So,
hey, Chris.
I could hear beeps then, and I could hear the audio, and I haven't even adjusted anything. So, I think all of my adapters are up here. I think my adapters are in a different part of the house. So what we're going to have to do is we're going to have to be a bit loose here. And have I got an end connector across here? I do. Let's use that. Luckily, we've got a lead I prepared earlier. Let me just disconnect that out. So I've got B and C out the back of the radio. And then I've got my dummy load over here in the corner. Just need to shift over. Connect it up. There we go. Cool. Now we connect that back up again. And I can hear audio. Now, I haven't adjusted anything at all with those potentiometers. Let's now connect. Oh, we've got a couple of people connected into that node. Let me just connect my private node. Okay. We should be connected now, guys. So if someone wants to call out and see if our audio is working.
I think it's a job for Freddie Mac.
I think so.
K85 FMU testing 1, 2, 3.
Haha.
There you go.
It's a little scratchy, I think.
See if you can hear me. VK7HH testing back. I have no idea what my audio is like.
Yeah, you're loud and clear, Hayden. My audio might be a little hot, I'm not sure. K85 FMU.
Now, there is a little bit of scratchiness there. You did mention that. Because we've breadboarded everything, there's RF coming out of the radio here, or next to all of these leads, all of these...
Which are little antennas.
Jumper wires, little antennas picking up all sorts of stuff. Now, that's where it leads. Now, thanks for that, Freddie Mac. I'll appreciate that. Now, that's where the daughter board comes in, where we've got shorter traces. They're all on surface mount traces. But I've also put in some RF filtering on here too, so that we don't get, those noises and those pops. But We just breadboarded that up in half an hour, and it's working. So,
and that's half an hour of explaining what we were doing. It's going to take you like 6 or 8 minutes.
Right. So, but do take your
Freddie's
time.
using his own Toads DI board. This was DI to DI.
Ah, sweet. So, I want to know what my audio actually sounds like. So what I'm going to do is I'm just going to dial the Parrot node just real quick, and I'm going to put a call out, which is going to be fun. Let's go. Oops. Let's go there and connect that in. Okay.
1, 2, 1, 2.
Someone else is testing on it, obviously.
That was a little bit hot. You should probably back off a bit.
That was a little bit hot. I love this Parrot. We need one of these for DMR. You sound a little drunk.
Someone else is using it at the moment. Let's try this. VK7HH is testing 1, 2, 3, 4, 5.
Audio level is slightly higher than average. VK7HH is testing 1, 2, 3, 4, 5.
Oh, it's because I doubled with the other guy. All right, I'll disconnect that because I think someone else is using it. But there you go. Call Plano. Is that a code? Does it tell you? Does it do something if you do that?
Who's Plano? Yeah,
that was that node.
Oh, okay.
Plano.
Christopher Giaquinto has joined. Thank you, Christopher. Welcome to YouTube membership. Now you're in green text.
Yes.
That just means you're smugly better than everybody else.
And I need to quickly do this. Hold on.
Oh, Darklight's going to know about the Bessel null and wants to know about how to set modulation without a service monitor.
He needs some milk.
He does need some milk.
Very
Look
good.
at that production value. When will these be available? Brian is asking. Brian, the U.S. version is in the air, coming to U.S. so we can redistribute them from the manufacturer to you. The Australian version is available for purchase right now if you happen to be in ZL or VK land. And then, if you wanted to pay extra shipping, you're more than welcome to do that. Just reach out to Hayden directly. My buddy Shane, Adventures in Blind Videography, $4.99 super chat. Thank you, Shane. Donkey Shane. Much appreciated. And we've got a question. Are you done with the overhead, or are you just monkeying around?
I'm just messing around. I can be done if you want.
Yeah, switch back.
All right. Be back soon.
Be right back. That's weird that StreamYard doesn't automatically hey, that camera's missing. Let's move this back to here. Awesome. All right, so we've got a question from my buddy Chris Bricker. Chris is actually pretty smart, so he's asking, he's kind of prompting us. I know what he's doing because I know he already knows the answer to this. He says, "How is this typically going to be used? Does the finished product going to have?" I get what he's trying to say. I'm not trying to make fun of him. Are we going to have a set of headers? So the original DI that you guys order is just bare sockets, bare through holes, as we call them in the PCB business. And you can do whatever you want. If you want to put a set of GPIO pin headers, like what you do on your Raspberry Pi, it's the exact spacing. You probably already have a couple dozen of them if you're into this. You don't need to do that at all. You can wire it up directly, or you can use pin headers. We are making daughter boards. You don't need a daughter board at all, as we have just demonstrated. Hayden, hold up that one that you did the direct soldering with all the components on it. The ugly brainchild.
This one.
Yeah, let me solo you there. So you can do just that, which is what we did on the breadboard today, but we did it a little prettier on the breadboard. And what you're going to get with this is a lot less of that interference because of all of the antennas, all of the DuPont wires acting like antennas. All right.
The reason why you could use this too is because you could mount this in the radio, and then you could
directly
have
inside.
And then you could build your own little circuit board or breadboard, solder breadboard, and you can design your circuit from there. Or you could interface it to your repeater controller. You could interface it to whatever radio that you want. So that's the idea behind that.
So one of the things that you see, and this is a big failure on the manufacturer's part in my mind. We have these things called 10-meter export radios over here. Do you have those, Hayden?
Yes.
So it's a radio that does 10 meters only, and then you go in and you bridge a little gap here, or you cut a wire there or something, and it becomes a high-powered 80-watt CB. We know what they're doing. They know what they're doing, but they don't really know what they're doing. So what we have seen is open up the radio, because if you open it up, there's one little tiny circuit board in this great big box. There's plenty of room to put this board inside, Dremel a little hole in the back for your USB connection, and you are good. I got that one. But thank you again, Shane. Yeah. And so you can have a 10-meter radio, like an entry level. What do they cost? Like $200-$300? I mean, they're cheap, quote unquote, compared to $1,000 7300 or 710 or FTDX10. A cheap radio to get you on FT8 or to get you onto APRS on 10 meters.
So in that case, I would get something like, let me just before I forget and put these away. So I got some of these. You can get these off of Amazon or AliExpress, the little headers. So you can put the headers on the top of the Toads board, and then I've got the sockets here, which are going on the daughter boards. Now the daughter board won't have this socket attached. We're not sure. We might actually provide these potentially with the daughter board so that you can plug them in. We've got to have a bit of a think about that. It's not that hard to get those. But the what's the Radio Oddity? It's a QT.
The RT95 is the one I'm playing. They have so the Radio Oddity, the 10-meter series. They have the QT40, the QT60, and the QT80.
Right. So this is what I was thinking of. This thing doesn't come with a method of connecting FT8 up to connecting it to digital modes like FT8 or something like that. So what you could do is you could put our little. Now I'm not saying that you could do it with this radio because we haven't done it with this radio. I'm just using this as an example. You could put a little hole here in the back for the USB-C to go in, or get a USB-C cable to go into the radio somehow, drill a little hole out. And then you could mount this board inside the radio, connect it up to find the signals, find the audio out, the audio in and out, the PTT. You could use the microphone connector here on the front as well. And then essentially you just plug that directly into WSJTX and you've got yourself, with Vox on this radio, if it has Vox, hopefully, you've got yourself a cheap way of interfacing. Do you want to answer that question from Adventures in Blind Videography?
Yeah, that's my buddy Shane, and it's funny that he says that he's not picturing it yet. I know what you're doing, Shane. I know. I see your games, my friend. I see it. I know you don't, but I see it. Little inside joke there between me and Shane. So it's not fully made with an enclosure, and somebody in the chat mentioned it a little while ago about there being a 3D printed case out there already, and I appreciate that. I'm not a 3D printer guy, so I don't know how to make those things myself, but this is meant for tinkering. This is meant for getting your soldering iron out and soldering components together. So
let's quickly, for those that aren't aware, jump into the Toads Discord. There's a link in the description below for this particular Toads DI channel. This is what Crashman39 has made. He's made a cheap, case here. Someone else has also made a. Where was the photo earlier? There was a photo. Here we go. Who made that? I think that was David made a 3D printed case. So there's a few people that are playing around with that. But one thing that I wanted to show off is, see, as soon as I open Discord, I get a million messages in Discord. Stop messaging me. It's in a private chat, right? And I'm not going to open it. This is what Darren's done. This is sexy. Look at this.
That is. Look at those standoffs. Look at everything there. Whew.
So he got access to a Toads DI daughter board early. As you can see there, that LED is horrendously bright.
Super bright. Brighter than the sun itself.
But he's got the standoffs going on here, and he's also looks like he's got the headers pointing up as well. So I guess he's going to connect this into something else as well. I think Darren's in the chat, so he might be able to explain. But that looks cool.
That's actually a really good idea. And so I want to know, like, my brain's already thinking, what can we do with an extra set of headers? So the daughter board is going to connect you to a Kenwood radio, an ICOM radio, a Yaesu radio that's got that 6-pin interface already, or you can cut the wire open and make your own. But could you connect to multiple radios? Could you control more than one radio? Could you send the audio somewhere else so you can hear it in your monitors and hear it in your computer? Yeah, Darren says, just for the future options, who knows? Yep, I don't know either.
Yeah.
So that's also an answer to Shane's question real quick, though, is we do have daughter boards that are almost ready for purchase in the U.S. I think, Hayden, what do you have, like 30 of them available?
Yep.
That you can plug this whole thing in, get it into a 3D printed case, connect it to your radio and your computer via USB-C, and away you go. Shane, I'll send you a private message. We'll talk a little bit more about it.
Yep. So, Chris, a 3D printed carrier that can hold the board while it is in the radio, something that can support the board for plugging. You don't need to necessarily have a 3D printed box for it because it has the Toads DI board has a 2.7 millimeter hole, I think it is, or the 2.5 millimeter holes on
it's
the
not 3,
mounting.
It should be 3. You should drill them if you get them.
So the next batch that we're going to look at doing, we will fix the text on the top of the board and fix the hole size. But you can drill them out just with a little M3 drill bit, and then you could just put it on some standoffs, so sort of like what Darren's done there on the standoffs, and then you could mount that inside your radio somehow.
So he's saying any recommended radios you're thinking of? Yes, all of them, every single one. But specifically radios that don't have USB audio on them already.
Everything it depends on your application too. Everything that supports what you're looking to achieve. So Allstar ideally requires audio in, audio out, PTT, and COS ideally, although I have an idea for that, which I didn't tell you about pre-show.
Don't be keeping secrets from me. I thought we were mates.
I reckon we can get your RT95 working without the mute, the COS, which is what you don't have.
Right.
Direwolf, I think audio in, audio out, PTT.
Yep.
Vara, audio in, audio out, PTT.
So Direwolf supports the CM108 directly, and FL Rig supports the CM108 directly, which FL Rig will then open up for you FT8 and JS8 and every other thing inside of the WSJTX software suite. You could do Whisper if you wanted to.
We probably need to do another stream on interfacing FL Rig to run with the board and get that working in WSJTX. Now that we've got the radio interfaced, we could do it with this FM radio. But yeah. The daughter boards will be available in the shop once we do some more testing. I literally only received them on Friday, and I've been busy all weekend, as we explained earlier on in the show. So I haven't had time today. I'm also fairly busy. So I'm going to get to it tonight, do some testing, and then we're going to have a discussion about sending some to the US and release them so that they're available for...
Yeah.
They'll be available for members, YouTube members and Patreon members of either of our channels early. So you'll get early access. So Darren is a YouTube member, and he got
membership has its privileges.
He ordered one of the boards, and I sent him a daughter board. That's a reject daughter board, but Darren's made it work, which is good.
Well, Darren got a discount too, so membership has its privileges.
So Shane's obviously a YouTube member. So Shane, you'll see the posts when that comes up, when they're available, first up.
And so Chris is asking,
oh, sorry.
You
yes.
Jump
yeah,
this one right here. Yeah, this one. There's too many cooks in the kitchen.
Too many.
Yes, inside the radio, this is where it gets weird because we don't own every single radio. And so, I mean, the easiest thing you can do is go get yourself some Kapton tape and tape the ever-loving mess out of it, stick it in the radio, and Dremel a little hole for your USB cable itself to come out the backside of the radio, and you're good to go. But in order to, I mean, could you imagine supporting like 3D printed models of every single radio internally? I mean, it would be awesome to take the Yaesu where it's got that USB USB, I think it is, connector, the printer cable connector, the device connector, and remove that, and then put this in its place with a second USB-C port, double stacked, one for cat control and one for audio out, because the FT891 doesn't really do audio out, but the FT891 does have a 6-pin port, so you could just use the 6-pin daughter board externally.
And we encourage you that if you have a radio that you want to use, to take some photos, post in the Toads DI channel in Discord, and then others can then help you out or can also suggest what they might have done.
Yeah. I don't have 3D printer design CAD file development skills anymore. Those have atrophied.
Well, see, I've been relearning the PCB layout and schematic skills, which is why I've been doing the daughter board. So,
we know what we want. We just don't know how to get there from here.
I know. Chris says, as far as I know, COS is only required for Allstar so that it knows when to transmit to the internet side. That's correct. But it kind of does limit you a little bit, though, if you can't do that, because the whole point of Allstar is to link up. However, there is a channel driver in Allstar which is called USB radio, which uses rather than COS, like a physical signaling line, it uses DSP techniques to listen to the audio stream to tell if there is a signal there or not. So that's what we're going to try with the RT95. So we'll see how we go. And Norm's saying that they can get some plastic boxes.
Oh yeah,
from
Buddy
the
box,
local electronics place.
Any plastic box. I mean, a pencil case from Walmart will get you just fine. It doesn't even need a case, really.
Now, someone was also asking about. I know that we were asking about people shipping to the UK, and I think our good buddy Andy probably wants to potentially get.
Thank you, Chris.
Get some boards or some people in the UK. I think offhand, for me to ship one board, obviously it's cheaper if you ship multiple boards. I think it's about $20 Australian, or just over $20. So it's like half the price of what the actual board is. I don't know how much that is in pounds. It's like £10, maybe £12, something like that.
I shipped one to Canada, and it was actually cheaper if he got a 5-pack than if he got a single, because the shipping was the same. These boards are like less than an ounce, so it's really like get 10, then you have 1 ounce.
I'm probably going to need to talk to a distributor over there. I know a guy that I could send some to. Yeah, I know a guy. So if we get enough people that are interested in the UK, then we can. Let's see. I can math on stream. Yeah, if we get enough people, then we can ship some to the UK. Mr. Kev has become a new YouTube member. Thank you very much, Mr. Kev. This one goes on forever.
You're not dancing? Dance, man, dance. I'll dance. I'll do the dancing.
Even when the music's not going.
I'm just dancing fool, man. Thank you, Mr. Kev.
Thank you. So, yeah. If we get enough people in the UK, then just let us know. Now, someone in the chat earlier, and I wanted to point this out, someone asked about the chip and how the documentation is hard to find on the chip. The chip is a CM108B. You can Google this, and it has all of the information on the chip. So if you need any more information on where the pinouts are, it's there. So,
isn't there a wiring diagram on that too, or schematic?
I don't think so.
One of them. There
diagram,
it is.
Block diagram.
One of them has a schematic in it.
Yep.
Chris would like a link for that. Drop that in the chat, would you?
We also had a question about the CM108 that we used, and someone said that it doesn't have a crystal on board, but this particular model doesn't. It's the crystal-less. The crystal-less one.
There's the CM108H that needs the crystal. The CM108B does not.
Yep. So that's even less. Even less. Andy says that he can send them out. I think that's probably the way to go, is to try and send.
We should make a Google form that says, how many people are you from the UK? Do you want this? Give me your address and information and blah, blah, blah. And then when we get the threshold number to make it worth it to you, it's always worth it to us to send it to you, but it might not be worth it to you to pay $20 to ship a $30 board.
Right. I don't know how much things are to send within the UK itself. I'm imagining that it's pretty cheap. Because like here, the cheapest I can send them without any tracking on the postal system is, I think, $5 in the size
I think it's the way it is here
bag.
too.
Yeah. Obviously, you don't get any tracking with that. And then I think double it, it's $10. That's when you get the tracking. So if you don't want to lose your... or if you want to be able to track where your boards are. It must be quite funny, though, because I'm using these large bubble-wrapped envelopes, or not envelopes, packaging, and it's got this little tiny board that's sitting in it.
Yeah.
All right. What have we got to clear up here? I think that's we've got through some of the. Yeah, Mike's. Yeah, that's right. That's right. The crystal oscillators, rather than external required, it's internal. Internal for the clock on board, the chip. Final comments, T.O. at all?
It's a great stream, man. I learned a lot. Thank you. Oh,
well, we got some. I was impressed. We got something working.
So in the links in the description of my stream, there are links for U.S. customers to get stuff on Amazon. Hayden hasn't gotten his links yet, but Hayden,
no,
mine.
I have.
Oh, Hayden's got links too. Mine have shown up. So next week we get to do this again, and I get to be the guinea pig. So these are the capacitors. These are the resistors. So I got a whole bunch of resistors in there, and then this one here. It's a little sketch.
Oh,
it doesn't have a label on it. It just says made in China. They put the label on upside down. So it
doesn't have the solder on all the pins like mine.
Inside. And then I got a transistor assortment. And this has got the 547 in it that we need?
So you can use a 547, a 548, or a 549. See how they're all NPN? I think you can use a 546 as well. Because for what we're doing, it's not really, yeah.
And then for real grins, I got a new radio that we might be able to play with. This one does not have the same pinout as the RT95, but this one just showed up today as well from Anytone. So there's that. I got the RT95. I have a bunch of RT95s for sale, so we're going to do that. And then it's Prime Day coming up on Tuesday in the U.S., July 8th. No, it won't be Monday's show, but Monday's is Q&A. I was getting there.
No, it's Monday for me. Just remember, it's Monday.
It's already Monday. It is Monday's show. Today is Monday.
It's Monday's show for me, and it's Sunday's show for T.O., but what you were going through is going to be
Tuesday.
It's going to be Tuesday. Tuesday's show.
Tuesday is Prime. Next Sunday / Monday, right here. This time, this setup. The two of us again. We're going to do another one of these. We're going to do this for a while because this is fun. But Monday night is the first Monday Q&A on ham nuggets, and we're going to have a special guest. We're going to have Mr. Farajay, Ben, Ham Radio Rookie is going to come on, and if you've ever had Ben on a live stream, he is just Mr. Excitement. He's even more exciting than I am.
When are you having Mr. Ben? Because I'm having Mr. Ben too.
For me, that's tomorrow.
Oh, okay. So you get him early then. I've got him. Let me have a look. I think it's the end of this month. I've got him.
So I got to tell you, Ben is doing it right. Ben has some products he wants to move. He wants to get his name out there, and he says, "Hey, can I come on your show? And let's do some magic. Let's collaborate. Let's do some things." You know, I mean, how many people in the chat read QST?
Well, I was supposed to have an article in QST this month, and it didn't appear in there. So I've got to ask the question where it is. So apparently, I need to be more useful. The old lottery joke. Yeah.
Thank you, Frank.
Don't worry. If I was useful enough, I would not be streaming online because I would have already won the lottery. they quit sending it out if you don't pay the extra for it. So I'm still waiting. I changed my membership to include the physical copy to be sent to me. However, I haven't received my first copy yet. That was
I need to buy
2
a
months
tablet.
ago.
I don't want to, but I need to buy a tablet.
Well, see, I forget. If I don't get it sent out to me physically, then I forget to read it.
It's really hard to take your entire computer with you into the bathroom and read the QST magazine.
Well, it's also unsanitary. I don't know if...
Well, no, I just use it to wipe and flush it. It's fine.
What, you use QST?
Yeah. It's
Or
very
you
soft.
You can't use the tablet for that.
No, no, you can't.
I don't know. I don't know if you can set notifications in that app to be able to tell you when a new issue drops. I think you
Right.
can. I probably got mine turned off, but yeah. So yeah, all right. Well, I think we're done.
On that note, it was very graceful.
Yeah. We'll see you next week for the RT95. Getting that wide up. Or the Anytone. Maybe the Anytone's got some pinouts that might work better. But I think we go back to the RT95 because that's the way to go.
Well, we got to get it finished, yeah.
Yeah. All right. Thank you very much. See you guys later. We'll end it there.